Assalamu alaikum to all of you. How are you all, dear students? I am Raza Ali Mugheri, physics at Cadet College, Pano. Today we are discussing about introduction of physics for class first year. As you have already discussed in previous classes from science, okay, what is the science and his branches. So we are only discussing about the introduction of physics now. The word physics has been taken from the Greek language word physikos, which means natural. The physics is an experimental science which depends heavily upon the objects and observation and measurement of natural phenomena. Or simple definition, the branch of science which deal with the study of matter and energy and interaction between them is called physics. Now what is the matter is? Matter is simply defined as anything which occupies space and having mass is called matter. Now the matter is further divided into three different stages. Number first is a solid, and solid is simply defined as the state of matter which has definite shape and definite volume is called solid. Now liquid is simply defined as the state of matter which has only definite volume but do not have definite shape. But the liquid quantity has a property whenever they can exist in any container, they can take the shape of container. After that we have gas state, and gas state is simply defined as the state of matter which has no definite shape and no definite volume is called gas. Now simply energy. Energy is simply defined as the ability or capacity of a body to perform some task or to do some work is called energy. Now the energy is further subdivided into two main forms. Number first is a kinetic energy and number second is a potential energy. Kinetic energy is simply defined as the energy which is causes the motion in a body is called as a kinetic energy, while the potential energy is simply defined as the energy which store in a body when it change its position at certain height. That energy will be called as a potential energy. Now the main branches of physics. The physics is divided into two main branches. In previous classes, we have discussed the physics is subdivided into 9 or 10 main branches. Here in first year classes, the physics is main divided into two branches. Number first is a classical physics, and number second is modern or quantum physics. Now classical physics is developed before 19th century and modern physics is developed after 19th century. Now the sub branches which including in classical and quantum are classical is further divided into classical mechanics, wave, thermodynamics, electromagnetism and optics. While the modern physics is atomic physics, nuclear physics and quantum physics. The question is why we have divided the physics into two main branches. Now, simple, the physics is divided into two main branches regarding the three basic things. Number first is classical physics is the physics which deal with the study of following things. Number first, the body which has large masses and low speed. Number second, it gives the macroscopic vision of matter, and classical physics is only physics which believes in Newton's law. So here are the few application of classical physics. Classical physics is a study of effective produced by force. Now simply here is a diagram that is given motion of car. Motion of car is studies in classical mechanics, loading on wheels and working of hydraulic machines. These all three are applications of classical mechanics which are produced by the force. Now, what is quantum physics? Here are the three postulations which are different from the classical physics. Therefore, we have divided the physics into two main branches. The first is small masses of a body with a high speed. It means that quantum physics or modern physics deal with the study of those bodies which has very small masses, but their speeds is very high. After that, it gives the macroscopic vision of matter. It means that In quantum physics, we study about all those particles or all those bodies which can never seen by our naked eyes. And then quantum physics is believed in Planck's quantum theory. Then we have an application of quantum mechanics, and quantum mechanics deal with the behavior of matter and energy. Now first is a smartphones, after that we have a electronic microscope, after that we have a magnetic resonance imaging. All these are application of quantum physics. Now Islam and science. In the field of scientific research, the strong initiative comes from no other book or no other philosopher, as it is comes from the Holy Quran. Do you not see how God made seven heavens one above the other? He has placed the moon as a lighting in them, and he has made the sun as a lamp. Surah Nu, ayah number 15 and 16. In this ayah, Allah Pak says that, have you ever seen the heaven and the moon that is lighting and the earth, all these? After that, surely in the making of heaven, the earth, and alternation of night and days, there are signs of people for understanding. Those who remember Allah Almighty standing and sitting are on their sides. Surah Al-Imran. Now we have a contribution of physical science by Islamic world. Here we discuss all the all the scientists which contribute in field of physical science. Physical science is simply defined as the branch of science which deal with the study of non-living things. Here we will discuss about the scientists, but the scientists are from the Islamic world and what they have contributed in physical science. And physical science is further divided into chemistry, physics, then mathematics, astronomy. All these are branches of physical science. Here the scientists who have those who have contributed in field of Islamic word. Number first is Jabir bin Hayyan. Jabir bin Hayyan was a chemist. He known as the father of chemistry. He derived various laws in chemistry on the basis of experiment. And Jabir bin Hayyan was a chemist. After that, we have Al-Batani. He was an astronomer, and astronomer simply is a study of astronomy, and astronomy is defined as the branch of science which deal with the study of astronomical bodies. Rest than Earth, all the things which we are seeing above, like sky, solar system, all these are study of astronomy. Al-Batuni was an astronomer. He made calculation in connection with solar system, the changes in season, escape of moon and sun, and other astronomical phenomena, which was discovered by Al-Batuni. After that, we have Al-Khwarizmi. Al-Khwarizmi was he was a mathematics. He was founder of analytical algebra. His famous book, treated as Hisabul Jabrul Muqabla, was the first work on his subject. He invented a term which was referred as logarithm. Then we have Al-Baruni. Al-Baruni was co-worker of Ibn al-Sina. He was an astronomer, physician, and mathematics. His famous book was Kitabul Qalun al-Masudi, is considered as encyclopedia of astronomy. Now, then we have the few contribution of Muslim scientists. Then Ibn al-Haytham. Ibn al-Haytham was a physicist. He was a philosopher of at that time. He wrote a book that was named as Kitabul Manazir. Then he invented a camera which was called as pinhole camera. Then there is a scientist which named as Umar Khayyam. Umar Khayyam was only the scientist who's known by the both a poet and a mathematics. Now we have measurement and system of unit. Very important topic that we are going to discuss. Measurement and system of unit. In the measurement, the first topic that comes, that is a physical quantities. Physical quantities are what? All the quantities which can be easily measured are called physical quantities. Whatsoever the quantity which are easily measured, it means which can be measurable will be called as a physical quantities. Now the physical quantities has been divided into two main groups. Number first is fundamental quantities and number second is derived quantities. So the fundamental quantities are simply defined as fundamental quantities are those quantities that cannot be expressed in terms of other quantities, or simply they are independent on its or they are depend on its own, which we simply called as a basic quantities. So here are the basic quantities are given, which are mass, length and time. Always the fundamental quantities are expressed in units. So the fundamental quantities are expressed in fundamental units. So the fundamental units will be defined as those units which express the fundamental quantities. As the mass is fundamental quantity, or we can say these all three: mass, length, time are basic. Mass is expressed in kilogram, length is expressed in meter, while time is expressed in second. So mass, length and time are basic or fundamental quantities, while kilogram, meter and second are fundamental or basic units. Then we have a derived quantities. Simply the derived quantities are defined as those quantities which are obtained from the fundamental quantity whenever we multiply and divide these basic or fundamental quantities. So whenever the fundamental quantities are multiplied with each other or divided, then the new quantities will comes, which will be referred as derived quantities. So derived quantities are also expressed in units, which will be called as a derived units. So the derived units are simply called as those units which express the derived quantities are called derived units. Here are a few derived quantities, just for example, force, energy, power. The unit of force is Newton, energy is power, while power is a watt. All these quantities are derived. After that, we have area, volume, velocity, acceleration, and momentum, torque. All the quantities are derived because they are obtained from the fundamental quantities. Then we have a system of unit. So the system of unit is simply defined as the set of fundamental and derived units is called system of unit. Whenever the derived units or fundamental units are combined, they make a system which is called as a system of unit. In physics, we have a four system of units which are given below. Number first is CGS system, number second is MKS system, number third is FPS system, and number fourth one is a SI system. Now we are defining all these systems in some detail. CGS system. CGS is stand for centimeter, gram and second system. In this system, the fundamental quantity was taken as mass, length and time. These are the fundamental quantities, while their CGS unit were mass was expressed in gram, length was expressed in centimeter, while time was expressed in second. That system is called as a CGS system. After that, we have a MKS system. The MKS system is stand for meter, kilogram and second system. The fundamental quantities of MK systems are the same which were taken in CGS system, which are mass, length and time, but their units are changed here. In CGS system, mass was expressed in gram or measured in gram, while in MK system it was measured in kilogram, and length is in meter and time is in second. Then we have a FPS system, and this FPS system is called foot pound or second system, or simply it is also called as a British engineering system. In this system, the fundamental quantity was taken as a three, which were force, length and time. Here the mass was replaced, and in the place of mass there was taken as a force, and the force called as a fundamental quantity. And their FPS unit is force is expressed in pound, length is expressed in foot, while time is expressed in second. Here in this system, in FPS system, the mass which we have already discussed in rest two system was fundamental quantity, but in FPS system, that mass is taken as a derived quantity. and the unit of that derived quantity is taken as salug. So in FPS system, the mass is a derived quantity and its unit is salug. But in other quantities which we have discussed, CGS and MKS, in that system, the mass was taken as a fundamental quantity. Now the last one, that is a SI system. So in 1965, the General Conference of Weight and Measurement recommended that a metric system of measurement was introduced, which was called as the International System. The international system was derived from earlier MK system, so that the basic three fundamental quantities are the same which are in MK system, and the four new fundamental quantity was introduced. In 19th century, it is known as a century of physics. The physics got very developed in that century, and many quantities were discovered. The earlier system was simply as an old system, and there is a lot of difference comes in the measurement of system. But in SI system, it was based on seven fundamental quantities, three which were taken from MK system, and the fourth which was newly discovered. And the seventh fundamental quantities are given here. Number first is a mass, length, time, electrical current, thermodynamics temperature, amount of substance, and luminous intensity. As we see the units in SI system, the mass is expressed or measured in kilogram, length in meter, and time in second. We have already discussed this mass, length, and time in MK system having the same units. Therefore, this SI system is also derived from MK system because the three same quantities of MK systems are the same which are given in SI system. While the other fundamental quantities are electrical current, which is measured in ampere, temperature is measured in Kelvin, amount of substance is measured in mole, and luminous intensity is measured in candela. After that, we have a symbol to express the fundamental or SI unit: mass, kilogram in kg, meter in m, second in s, ampere in a, Kelvin in k, mole in mole, and while candela in cd. Then we have an important topic which is called as a dimension. Here the word dimension has different meaning. So if we discuss the dimension in literature, it means line or direction. Or if we see the meaning of dimension in mathematics, it is a simple mean axis. Now, what is the role of dimension in physics? The word dimension has a special meaning in physics, and what is that special thing is it shows or it denotes the nature of physical quantity. Means all those quantities which are measurable, their nature are expressed by a physical or by a quantity which is called as a dimension. Now the dimension of basic quantities are already given. Basic quantity means that simply we have already discussed which was called as a fundamental quantity, and there are three basic quantities: mass, length, and time. The dimension of these basic quantities are already given as mass. The dimension of mass is expressed in M capital, length in L capital, while T time is in T capital. All the rest quantities are simply called as a derived quantities. Therefore, the dimension of derived quantities are obtained from these basic quantities, and this basic quantity means mass, length, and time. Their dimension will be M, L, and T. Now here is a important term to discuss. In physics, the number and ratio has no dimension. It means that the number has constant value. Therefore, in physics, the constant value has no dimension. And the other is ratio. Ratio means that it is a same quantities. Whenever we divide the same quantities, the net result will be zero. Therefore, the same quantity, whenever they will be divided, their dimension is also zero. Now the dimension of distance, displacement, and their unit is a meter, or it will be mile, or even light year. These are all the unit of distance but their dimension is same, which is L capital. It means that if we measure the distance in meter, or if we measure the distance in mile, or if we measure the distance in light year, the dimension will be always L capital. Now we have a dimension of derived quantities. How to obtain the dimension of derived quantity? The dimension of other quantities can be obtained from the basic quantity. Already we have discussed the fundamental or basic quantities, which are mass, length and time. All the other quantities will be called as a derived quantity, and their dimensions are obtained, or the derived quantities are also obtained from the fundamental or basic quantity. Therefore, the dimension of derived quantities are also obtained from the basic or fundamental quantities. Here are given. The first one is the velocity, acceleration and force. As we know, velocity is what? Change in displacement upon time. Simply, we are dividing the distance displacement with time. Displacement is what? It is simply distance. The distance is what? Distance is length. So the dimension of length is L capital. And second is what? Second is the time, and the dimension of time is T capital. So the dimension of velocity is L upon T. So as we shift the T, it will comes in multiplication form, but its power will be changed. Now it would become in negative, so lt minus 1. The acceleration is same dimension, lt minus 2, and the force is mlt minus 2. Then we have a dimension analysis. This dimension analysis is a method which is used to check an equation in physics ke either that equation is dimensionally correct or not. In dimension analysis, we are correcting the equation from right hand side to left hand side. If their dimensions are come to equal, it means the dimension which is coming from left hand side is equal to right hand side, then that equation will be called as a dimensionally proved. Here is a simple example we are getting to explain the dimension analysis. That is the second equation of motion, which is S is equal to VIT plus 1 upon 2 AT square. Now we want to analyze its dimension. For dimension analysis, what we are doing, first of all, we are making the data. Why we are making the data? Because in that equation, the few quantities or few physical quantities whose dimensions are already known. As we know, s is the distance, so the dimension of distance is L capital. Vi is the initial velocity. Remember one thing, either the velocity is initial or final or change, its dimension is always same, which is V upon T. So the dimension of velocity is L upon T, and the dimension of acceleration is L upon T square, and the dimension of T is T capital. Now putting all the known dimensions in the equation, we are placing S is equal to VIT plus 1 upon 2 AT square. In place of S, we are placing L. In place of VI, we are placing L upon T into T capital plus 1 upon 2 L upon T square into T square. Now T and T will be cancel out each other, and T square and T square will be cancel out each other. Then our equation become L is equal to L plus 1 upon 2L. Now here 1 upon 2 is a ratio, or simply you can say it's a number. And in previous slide we have discussed that ratio and number has no dimension. Therefore 1 upon 2 will be skipped because it has a no dimension. Then our equation will be L is equal to L plus L. Now here we have a same quantities, but there is a addition sign. In mathematics, whenever we have a same quantities and the addition, then we will always add their coefficient. So L plus L will be equal to 2L. Now L is equal to 2L. Again the 2 is a number, then it has a no dimension. So finally the equation will be equal L is equal to L. It means that this equation is dimensionally correct. Significant figures. What is significant figures are? They are simply defined as significant figures are the reliable digits in a number that known with a surety or a certainty. For measuring or for counting a significant figures, we have a certain rule to determine. Number first rule is all non-zero digits are count as a significant figures. So before discussing this, you have might learn about the numbers. So there are two types of number. First is a constant and second is a variables. In constant, we have two digits. First is a non-zero, second is a zero. Zero contains only one digit zero, while the non-zero contains from 1 to 9. These all the rules are based on from 1 and 0 to 9. Now in rule number 1, all the non-zero digits are counted as a significant figure. Here is the example 3, 5, 7, 6. Now in this example, all the digits are used are non-zero, therefore they will be counted as a significant figure. So in this number, there are 4 significant figures. Rule number second, if the zeros in between the non-zero digits, they will be counted as a significant figures. So zeros, whenever they will become in between the non-zeros, they will be counted as a significant figures. Here is the example 5, 3 zeros, then 6. Now here in this example, the zeros are in between two non-zeros, therefore they will be counted as a significant figures. So in this example, there are 5 significant figures. Then rule number 3, 0 locating a decimal point in a number less than 1 is not counted as a significant figure. If the number is starting with a non-zero and then there is a decimal point, rest all the zeros will not count as a significant figure. Here is the example that 0.00036. The number is starting with 0. After that, there is a decimal point. Rest zeros will be not count as a significant figure. Therefore, in this example, we have only the 2 significant figures. Now, rule number 4. In rule number 4, if a number is greater than 1, then all the zeros written to the right of decimal count as a significant figure. For example, 3.0500. If a number is greater than 0, it means if a non-zero number is starting in example and there is after that non-zero there is a decimal point. Rest whatever should be there, either it is a 0 or non-zero, they will be count as a significant figure. So here in this example we have a 5 significant figures. Now rule number 5, and in rule number 5, the zeros before or after a non-zero will not count as a significant figure. If a number is starting from 0, in between there are non-zero, after that there is also 0, then only the non-zero will be counted as a significant figure, rest all the zeros will not count as a significant figure. So in this example we have only 3 significant figures. Thank you very much.